Welcome aboard, guys. Let's get started. The new lecture. This is the fourth one, I think, about the soil texture. We'll cover all the important details that have been left with the last lecture. So we'll cover these all the things here again. Okay, let me just switch the things fast. We'll go with the lecture. Okay. So we did study about lots of things. We'll start from here about the soil texture. So if there is a noise from my side from the background, I would be, I would love to, sorry, I would like to be apologized for that. So I already said I live in a house. There is a lot of noise. I do have lots of family members, so that is the reason that I have this kind of stuff just in my background. Okay, that is not a matter to study. Right, let's come to the soil texture again. Okay, so but there are the five, there are the four textural group in the soil. Textural group is what there may be the percentage difference. Like mm, we we said the this soil texture is a sandy, this soil texture is a clay, this soil texture is the porosity. So there should be the limitations, like there should be the percentage about that we hold that that particular soil will become under this texture. So that is the soil texture. How much amount should be how much amount should be the soil particles? So we can call it sandy texture group. So there is a amount is mentioned here. There should be 70 more than 70% of sand in the soil, and at least less than not at least less than 15% clay. There should be the sandy textural group. Which soil come under this? This soil have more than 70% sand and less than 15% clay. So that soil textural group will come under the sandy text. All right. Okay. Move to the next one. What is a clay texture soil? Again, from one nobody said all. So clay texture is what? Soil which contain the more than 35% of clay percentage. Sometimes you may see the 40% in the examination, but more than 35%, that would become which textural group? That is clay texture. All right. There is a number third. Number third is loam texture. So what is loam texture is about? If the soil have there is a simple ratio. This soil is considered as a loam 40, 40, 20. Simple as that. 40 is what? 40 is sand, 40 is silt, and 20 is clay. If this is the percentage of these particles in particular soil, that will be considered as a loam texture. Alright, there is a one more soil textural group that is silt. Silt soil. You can call that soil as well, like it's a soil textural groups. Okay, so it's silt. If soil have more than 80% of silt and less than 12% of clay, that soil will be considered as silty soil. Simple as that. All right. We covered what? You just repeat. You can just revive these things. You can pause the lecture. You can revise it again. You can revise something. Okay, let's move to the next one. I think it's a very simple thing that should not be the very highlighted. Okay, let's move to the next one. Okay. Okay, so where is my pencil? Okay, cool. So which one is the soil textural class? How we can identify? There would be lots of, let me just tell you, there are the 12 soil textural classes. In case of that you do not know, the particular name of that particular soil classes, soil textile classes. So how you can identify if you face this kind of question in the exams? So there is a simple trick. To solve the question is simple as that. Let read the question first. Which one is not a soil textile class? So sandy loam, clay, or silt clay. So how we can identify which one is not a soil textile class? So there is a trick to solve these questions. Trick is very simple. Soil textile classes do not end with the void. Exception clay. Soil textile classes not end with the void. There is a no end in the soil texture classes. There is no void in the end of soil texture classes. So for that, for mistake. So there is an exception also. In clay case, there can be the Y in the end. That would be the soil texture class. But ex except clay, except clay, no soil class have Y in the end. In the end. Alright. So we'll go through with the one by one. There is sandy loam, clay, and silt clay. Silt clay, there is a clay in the end, but we already discussed that in case of clay, there can be the void in the soil textile class. So it may be the soil textile class, there is a clay. It may be the because it has void in the end, but it is exception. Sandy loam or sandy. There are two. So sandy loam do not have a Y then, so it will be considered as soil textile class. But in case of sandy, there is Y in the end. And what was the rule? The rule was soil textural class. Soil textural class do not end with the Y. It Y. There is no Y in the end, except clay. In case of clay, there can be the Y in the end, but except clay, there should be not the Y in the end. But there is sandy. There cannot be the Y in the end if it will come in under the soil texture class. So this Y make this option right for this question. All right. So this is not the soil texture class because it will end with the Y. The, in case of clay, it can be the Y in the end because it is exception. All right. I think it's clear. It's a very simple question. It's like you can solve in nursery class as well. So we do not have a waste lots of time on that because already we got 3 lecture on the soil texture. We don't want to exaggerate the things. We don't want to make it too long to complete only one topic. So we do have what we do have go through with the right speed, right? Okay. According to USDA, soil texture classes are 12 in the number. How many soil texture classes? There are 12 soil textural classes. So textural classes. Textural classes. How much in the number? 12. By USDA. What is USDA? I already told you so many times. United States Department of Agriculture. So what are the 12 classes? How we can remember that? We there maybe we can make the trick way as well. If you will guys will comment in the below of this video, we will make the trick on that particular, but we can learn here as well. Firstly, we'll learn these 4 things like first number have set, 4 number have low, 6 number have shift, and 12 number have play. We'll learn the individual part first. All right. Sand is the first number always in the classification. Also, we do first thing we do right about the clay. Clay is the last one. Then we have the 4 number, that is low. Then we have the 6 number, that is silt. So, what is the method to remember these 12 classes? They're simple. We'll write the individual soil particle. We'll remember the number of individual soil particles. Sand have the first, loam have the fourth one, silt have the 6 1 and clay have the 12 1. So what we have to do? We have to do just, if there is a clay, we'll start from the lower one. So we'll go through the, like what we learn, what we learn in previous classes. There are the three soil particles: sand, silt, and clay. And clay. What is the size sequence? It's a bigger one, it's a medium one, and it's the smallest one. So how we will go through this? We will go through. Okay, let me write first. 10, then now 9, 9, then 8. Okay, let's remove it. Then 7, then 6. Sorry for that. Then 6, then 5, then 4, then 3, then 2, then 1. Okay. Let's learn how we can call these 12 classes. Okay. First, we'll go with the clay. It is the smallest in the size. We already write there should be the silt, there should be the long. We'll remember this thing. First will come. First we'll start with the same. Fourth one is long. Sixth one is silt. So what we'll learn? Last one is a clay. So what there three phases there from the last. We'll start with the clay series. So there is a sequence like bigger one. We'll go in this direction always. So clay series, what said? This soil particle will come just before clay, that is silt. So write silt here. Then this series it is a clay series. So just write it. This particle is bigger than silt, that is sand. Then this series is this clay series. Simple as that. Can you remember this? Just you can remember the name as well, guys, like sandy or sand, whatever it is. Okay, we remember like this. We write down the clay in the lowest on the 12 number. Then this is the clay series. We'll type according to their size, which will come, which soil particle will come before just clay. That is it. We'll we we will add clay. After that, then now sand will and we will add clay. That's all for the compounds. All right. I think these three things are clear to you. Then this series is next one. Clay long series. Okay. There is clay long series. So again, there was a clay series. There is a new series will come after this on number 9. That is clay long series. Again, we'll start the same thing. Which soil particle will come after the before the clay? It would be the silt. So silt clay long because it is a clay long series. In 9 from this series will start clay long series. So clay long will be right on the 9 number. And on 8 number, silt long, silt clay long. Then which particle will come just before clay one, that is a silt. We'll add the clay long just before that. Alright. Then which particle will come just before a silt? That would be the sand. Then we will add the same thing just behind. That is clay long. Alright. So I think it's clear to you. We are going right or not? Let me just check. Clay long on 9, silt clay long, sandy clay long, and silt. We already write the silt as well. I think the half part is clear to you guys. This trick can be easy for you. We can make more tricks for you. It's a my trick, by the way. Let me just tell you. Okay, how we can remember these all the things that is above. We'll just remember that we plus them, but their sequence would be, we will remember the sequence only. What we'll do? We will plus them. Okay, the sequence one time this one. The sequence would be आगे पीछे कुछ भी हो सकता है. Sometimes send will be ahead, then sometimes long will be ahead. So we'll remember just this is the long is sent, and there is a sendy long, sendy long. All right, simple as that. We know already long zone number 4. We let them. It would be simple as that. Set long. Good. All things are clear to you guys. I think it's very clear to you. You should not waste lots of time. I don't want to make 2 more lecture on the same topics on soil texture. I want to cover this soil texture in this lecture only. So we can start new lecture from the next video. All right. I think it's easy to. If you guys find this trick easy, please write in the comment. So it would be boost my confidence to make some more videos on that. Good. Okay. Let's go to the next one. Okay. How identify what is the dominant soil particle in a different soil texture classes? How? Okay. If you imagine that there are the lots of soil texture in front of you, cool, so for that. Alright. If in front of them there are the lots of soil texture, silt clay, clay loams, and so how we can identify which is the dominant in that particular soil texture class? So it is very simple. What is the trick to identify that this soil particle is dominant in that particular texture? We will simply read the soil texture group name. What will be what we will get in the end, that would be the dominant one. The trick said to us, what will come in the end, that would be the dominant one. Okay, that's me in this first one, silt and silt clay. The clay is dominant one in that particular soil texture class. Silt will come to next after just clay. Okay, in clay loam is dominant one. Then then will come clay. Okay, and sand itself and sandy clay. There is clay is dominant in that particular that sand. All right, I think it's a very simple like to remember this. So question: which soil texture class having the highest water holding capacity? Pause the video. Just try to solve it. If you do not find the answer, just take. It's your goal. Take answer on this question first. Then you can go for the. You can go with me. Okay. What is how we can solve it? That already we know that which soil particle will come in the end, that would be the dominant. All right. So maximum properties would be come from that particular dominant soil particles. So we know that this soil particle carry the highest water holding capacity. That is the clay. Simple as that. So in that particular soil texture group, if soil have maximum clay particle, so it means that soil texture group have maximum water holding capacity. Simple as that. We already discussed about that. So we'll find which soil has a clay texture maximum. There is clay in there. There is no clay, so it's out out of our option. So we can eliminate this. Simple as that. There is no clay. We can cross it. So there is again clay. So there are the 2 options we end up with. That is a silt clay. There is a sandy clay. So which one? The next thing we learn just here, just before this silt. Each soil particle will come in the end, that would be the dominant. Then next would be the second dominant. So in that we know that there is sand, there is silt. We know that there is a clay. That means there is a water holding capacity is maximum in both of them. But one have sandy more, one have silty more. So in which silt have more water holding capacity because of micropores are more compared to sand. So that all the things we already learned. So we will go with this answer. What it's depend on the sickness. What would become in the end? There would be the maximum. uh, According on that, the properties would be decided. All right, simple questions. I think you guys also enjoying the same thing. Like, let's go to the next one. Okay, so interesting part is here from interesting part will be start from here. Sorry for the long sentences. Okay, cool. Determination of soil texture classes. How we can determine the how much soil particle exists in that particular the soil texture class is there. There are two methods generally. We do have in the world, that is the field method. Then second one is mechanical analysis. There are the two methods to determine the soil texture classes. First one is field method, and second was the mechanical analysis. Mechanical analysis itself further dividing in the two part. That two part or two types. The first mechanical analysis method is International Pipette method, IP, IPM, but it is not that IPM related waste management, entomology. Okay, this is not our topic. The first one is International Pipette method. Then second one is the Picus hygrometer method. All right, two methods. Which one this? These two that are first one International Pipette method, then second one is Picus hygrometer method. All right, let's jump to the next one. Are you guys with me? Yes or no? Just type yes in the comment section if you are. Okay. Let's go through with the first one. What is the field method? How we can determine the soil texture in pipette by this method. So field method, what is the process step by step? First, we'll take a small soil sample of 25 gram and remove the gravels and stones. First step we'll do what? We'll take the 25 gram of soil sample. Did I say 25 in Hindi? Sorry for that. Okay. Yeah, it's my mother tongue, so sometimes I'm sorry for that, but let it be. Okay, cool. First step is that we'll take the 25 gram soil sample. We'll remove the post fragment, that gravels and the stones, then motion with the water until reaches the plastic on bulk because do not wet. Then second step will be, we'll do 8 bit of water in that. Not too much, will not make it wet, but it will be in will add that much water, it reach on the plasticity. There can be the consistency as well, but not too much wet. All right. Plasticity and consistency will read ahead. That is a very interesting topic. Okay. Then we rub between the thumb and forefinger. What we'll do? We'll take after this in our hand and we'll rub between the thumb and four fingers. So what we'll feel if the feel is gritty, then we call it sand. It's very important. It will come in the examination. All right. It's very important. Appearance is gritty, then answer would be the sand. If appearance is the talcum powder, then answer would be the silt. What is talcum powder? Talcum powder, you can simply remember by that there is a white cement or there is a white cement simply is the talcum powder, like that. The same thing we have. If the feel is smooth, is soapy and talcum powder, that answer would be the silty. And the third one, sticky, if the appearance is sticky. Sticky is what? Like a bit of weight can form the ribbon, which can form the ribbon as well. So the answer will be the clay. Gritty goes to sandy, talcum and smooth is soapy goes to the silk one, then sticky goes to the clay. These things are very important to remember. That the things that will appear in the examination. Tighter formation are repeated by the process of placing the soil between the thumb and forefinger. What we will do the next thing, that field method is done here, but we can go for the more accuracy reward. So we can identify the classes as well. If you rub the soil in between the thumb and forefinger, if there is a no ribbing, what is the ribbing formation when we, place the soil in between the forefinger and thumb? There is a, like, it will be break in this formation, but in case of sand, there will be the broke, there would be the no ribbon formation. But if in case of silt and clay, there will be the ribbon formation. So, the things we are talking here. Try forming a ribbon by pressing the sole between the thumb and forefinger. No ribbon formation break quickly. It appearance that goes to sandy. There is a no ribbon formation in the sandy soil. It will be simply break down. Short ribbon less than the size of ribbon is less than 2.5 centimeter, then it goes to the sandy clay, long. Simple as that. Long or sandy clay long. Medium ribbon formation 2.5 to 5 centimeter clay long or silty clay long, and long ribbon more than 5 centimeter, very sticky than clay. Simple. There are the limitation of the field method. What is the limitation? Accuracy depend on the experience of the person. Imagine that we do not know anything about the field method, and first time we are going in the field and we read these things, but we cannot estimate the right thing exact, because eh, we did not practice it just before to go on field. So we do not have an idea about it. It's all about the experience. It's all about the practice. It's all about the how much experience you have. So it's depend on the experience when we go to the field. So less precise than the mechanical analysis hydrometer. Okay, it's as simple as that. Instrument have the more accuracy level shown here. Simple as that. That's why we call them technologies that advanced. Okay. So field method is done here. Let's go to the next one. That is the mechanical analysis. What is the mechanical analysis? Let's learn the mechanical analysis. What mechanical analysis said was, okay, mechanical analysis is the method used to determine the proportion of soil separate smaller than the 2 mm in the diameter. The soil particle, their size is less than 2 diameter, less than 2 diameter, 2 mm. Sorry, the size soil particle size which carry the less than 2 mm, that is determined by mechanical analysis. Put that the whole soil particle, three of them have like the same size. Okay, cool. What we have to do in mechanical analysis, soil sample collection and preparation. First step, we'll do soil sample collection or preparation. Collect the soil sample, remove the organic matter, salts, and carbonate using by the. Okay, I don't want to go in too much deep into this. This is the stuff like you can read by your own, but the things that are important, they come in the examination from this stuff that we'll discuss. Okay, first we'll collect the sample. We'll do the prepare soil sample. How we'll prepare? Like we'll remove what organic matter, salts, carbonates, and breaking of aggregates. How we'll do this? How we'll do these things? We'll do with the adding the certain amount of chemical and different type of adding by different type of chemicals. So they will help us to do these things. So first we'll do the dispersion of soil particles. First, what we have to do, like organic matter. Okay, collect soil sample and remove the organic matter, salts and carbonate using hydrogen peroxide or HCl if needed. Okay, organic matter is removed by H2O2, that is hydrogen peroxide. What we do in mechanical hydrogen peroxide? What we do remove the organic matter from the soil sample, which is done through the H2O2, that is the hydrogen peroxide. We'll add the hydrogen peroxide in the soil sample that will remove the organic matter from the soil sample. All right. Then dispersion of soil particles. They mentioned that they are the clay. They have the more attraction between each other, so there is a high cohesion. So how we do make their dispersion, like how we can separate them to each other. So there is things we have to use, that is sodium hexameta phosphate. Let me just type here. What is dispersion mean? Dispersion means simply is that if they are in the group, in a tight group, we just do have to separate them by using that chemical. That that chemical is known as dispersing agent. What is the that dispersing agent is that? That dispersing agent is that, okay, sodium hexametaphosphate. Sodium met sodium hexametaphosphate is the dispersing agent. It will separate the soil particles to each other. Okay, sodium hexametaphosphate. Or the another things we can use is that sodium carbonate. That means sodium do the work for what? For the separation of the soil particles. If soil have high sodium amount, then that soil will be not good in the properties, because there is would be the lots of dispersion. That sodium hexametaphosphate and sodium, let me just like this. That sodium hexametaphosphate and sodium carbonate together, this known as Kelkon solution. What we call this solution is known as Kelkon solution. What is the percentage amount? 40%, 10%, 10 grams. Sorry, what is percentage? What is this? Okay. All right. What is Kelvin solution? Both of them together that used for the dispersion in the soil of particles of soil. So that is work as the dispersion agent, that is known as a Kelvin solution. Then stack and suspension, particle don't stick together. Separation of soil particle by size, too common. We do separate by the too common method. If size is bigger, then we use the CO method. We do we use the mesh and we sew the sand or soil with this. And the another method, if the particle is sealed and clear, then we use the sedimentation that we learn ahead. Sedimentation. I think we should end the lecture here. If let me just check to the next one. Next slide. Okay. We will not end lecture here. We'll go for this slide as well. What is this? What this slide say was? What this slide said was, let me just go through it. Okay, cool. Okay, there is one thing we forgot. There is calcium carbonate and R2. What is R2? That is sulfuric oxide. Oxide. What is that? It is the oxides of aluminum and iron. These oxides of aluminum and iron is known as sulfuric oxide, that we represent them by R2 and calcium carbonate. It is removed by HCl. Okay, there are the four things we learned. R2 or calcium carbonate is removed by HCl. Organic matter removed by H2O2, hydrogen peroxide. And dispersion is done by sodium Kelvin solution. Simple as that. Will not go in chemical formula. Cool. Use all things are clear to us. I think we should try in Hindi as well. Like their lecture can be the more interesting in Hindi. Like, because there is my mother tongue. Because of I'm saying, like just before 2 days, I say to you guys like your future in English. Like I want to see that. I want to see like why people are not joining in these classes. They are not interested. So we can go for the Hindi one. Just check the what is the feedback. So just check to the what people think. So we'll not go through the Hindi for the next one, but we can experiment. Okay, cool. Let's understand the part. Let's finish this slide. We'll later on we'll talk about that. Sedimentation, hygrometer, and hygrometer. There are two methods I already told you. There is a mechanical analysis method. Soil suspension is a place. Suspension is placed in the cylinder filled with the water. These are like procedure kind of things. I think this particle settle their taste is measurement. Okay. It is talking about the sedimentation. Okay. Sedimentation is followed in both methods. Soil suspension placed in the cylinder filled with the water and this particle they said this is simple like what is sedimentation? We place the soil in the cylinder, there will be the water, they'll go down with the rate of flow that is known as sedimental. Simple. Sand settle quickly, we know because that is bigger inside. Size particle are bigger, they'll quickly settle down. The particle size are bit of small, then goes bit of slowly. Then if the particle size are very small, then they'll take very long time to settle down. Simple as that. Sand will be settled down within the seconds, then silt will settle down with hours, but clay remains suspended for long days. Like it will take a day, days to settle down in the water. Instrument like hydrometer pipette used to measure the particle concentration at a specific depth and calculation of soil separate from the weight and percentage of said clay. There is soil set. Okay, what is the soil texture detail determination? That is the right here. Okay, there is no, it's important. That's why I ignore too much deep into this. Okay, let's see what is the next. Okay, the same things. Is come again, what is that? We already discussed about that. For removal, okay, the one thing I want to tell you here is that these things will come in the examination. What is important from the mechanical analysis, these things we are discussing right now, that already I told you. H2O2 is used for removal of organic matter. Okay. The calcium carbonate and R2O is removed by SCl. And the dispersing agent is sodium hexametaphosphate metaphosphate plus sodium carbonate. Good. That together we know that calculum solution. What is the percentage? 40 grams sodium hexametaphosphate and 10 grams sodium carbonate. That is the percentage of this stuff. Good. Let's jump to the next one. Okay. Mechanical analysis is two method. That first one is international. I think we should cover in the next. We'll start from here in the next lecture. Otherwise, lecture will go too much long. Thank you, guys. Thank you so much. Good to see you all.